Well, hello there. Good afternoon. It is Friday, October 25th, and I am Rob. Around here, that developer dad. Scud just popped into the chat and said, hello, Dad. Hello, Scud. And I'm going to pin this little thing I just popped into the chat to let people know what I'm doing. So this week I've been specking out and I am a .NET Core developer. Yes, I am. And prior to that, I was a .NET developer. I've been slinging code for a very long time, Scott. Like a couple of decades at this point. So, yes, some ASP.NET. What I'm currently doing with this project is I've got a ASP.NET Blazor application that is going to help me run my D&D games a bit more smoothly. The very first feature is just a commoner NPC generator, because my players are always asking me for details about the townsfolk that they run into on their adventures, like the blacksmiths and the tavern servers and bartenders and shopkeepers and all of these people that they meet. They want to RP with them, and they're always like, hi, I'm such and such, what's your name and what do you do, and blah 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 blah, and they get right into that stuff, which is awesome. But I'm not always as quick on my feet as they are, and they'll catch me flat-footed. So I wanted a way to spin up NPCs very, very quickly. So I've built a Blazor application. It's hosted up in Azure. I do need to replace the storage mechanism. Right now I'm using Azure SQL Database. And the free tier, it goes to sleep if you leave it alone for a couple of minutes. And it takes a while to spin back up again. And that's no good for when I need something quick and in the moment. So I'm going to switch over to Azure Storage Tables. I'm probably going to do that just during my non-streaming times and stuff like that, because what I'm doing right now is I'm building an application to automate the tasks that I would have to do when somebody signs up for a subscription to this thing. Once I get it configured and set up, they're going to go to like a storefront. I did some pricing between Azure SQL Database to have it running 24/7, and that's going to run me like between $300 and $400 a month. So that's a big fat nope. I looked at Cosmos, and for the amount of data that I project that I'm going to be storing, it was looking like it was going to be $5, $10, $15 a month. And then I looked at Azure Table Storage, and it's going to run me like 50 cents. And it's fast, and I don't need all the referential integrity and all of the SQL goo that comes with SQL Server. I'm just looking to store tables of semi-structured information. And yes, Cosmos would fit that use case, but I don't feel like I need global scale yet. I can also very easily migrate from Azure Table Storage into Cosmos for tables later on, because it's actually the exact same SDK is used. I believe the difference from a code point of view is the connection string. I'm going to start with Azure Tables. If I need Cosmos, I can go to Cosmos. I do have to rewrite my resource access providers. Azure Tables is basically just a kind of storage account. Super cheap. It from the tire kicking I've been doing over the past couple of days, it's super fast. Certainly fast enough for my purposes. I don't need, picosecond response time or anything like that. So it's going to do the trick. But this week I've been building an admin system for that, because I don't want to have to be always watching my phone for emails from the ecom service provider I'm going to be using that, oh, somebody just signed up, I have to go do their stuff. Right now I'm using 8 SCOD. And I need to be able to validate subscriptions and customers and all of that stuff as my backend responds to events coming in from the payment processor. I'm really curious about .NET 9. I might do some tire kicking, but when it comes to production code or code that I need to live out in the wild, I have a strong preference for the even-numbered long-term support versions of the framework. So what I'm doing today is I'm finalizing some experiments that I've done around dynamic rules, where the definitions of those rules can be serialized and stored in a database, a JSON file, a text file, whatever, and then brought in and rehydrated at runtime, and then executed against instances of some type, so that I don't have to type in, if object.property equals this, then, and so on. I've kind of figured out the abstractions that I need to basically give these rules a name, the type, or the type name for the subject, and the subject is the object that the rule operates against, the type name for the property that we're concerned with, the name of the property, obviously, what kind of operator we're running, and some object that the rule is going to compare that property value to determine whether the rule passes or fails. Now, I need to add some some comments here. Plain language name for the rule. The type name for the object that the rule is applied to. I'm currently I think I'm just using global server. I've got it set to auto, and I am not using JOT for authentication. I'm using Entra, and I'm not using WebAssembly or anything like that. I'm doing server-side interactivity right now. If I move over to client-side, like with WebAssembly, I'm going to have to switch over to using JOTs for that. Type name for the property that the rule is applied to. The name of the property. Yeah, it's currently at the global scope, I believe it's set to automatic, but right now I'm just using server. It's whatever it does out of the box for .NET 8. This is actually my first Blazor UI that I've ever written. Now this project, it's a console app right now. And let me share my screen. I'm just commenting stuff as we go. Identifies the operator that this rule uses. The name of the subject's property was applied to. The value used to compare the subject.property to when determining whether that subject instance passes the rule. Yeah, normally, like for the past, I don't know, 10 years or so, 90% of my working life has been behind the API layer, so I haven't done a whole lot of front end stuff. Not much, anyway. And I became unemployed in May due to, procedural layoffs. I think they were calling it payroll optimization. And I started doing this streaming and just kind of demonstrating my architectural and design process and so on. I am running out of runway. I'm looking for work. Ideally remote, based in the US. But while I'm waiting for interviews to happen and stuff like that, I'm doing this. Yeah, I'm a .NET dev, but I'm having a heck of a time getting past the applicant tracking systems, man. I'll submit my resume to like 6 places on Monday, and within 24 hours, I've got the automated email back. Part of my problem is I didn't go to college for software development. I went to college for music, and I didn't even finish because about 2 months into my second year of college, I got into a band and started just doing music for a living. And I did that for most of the 90s. So it didn't make much sense to go pay somebody to sit in a room and listen to them talk about what I could go out into the world and get paid to do later that day. So rule definition, okay. Now, I've got this remaining tasks file that I created. Where the heck is it? Here it is. Second submission, they called me for the interview too. Yeah, it used to be. Up until partway through last year, I was getting contacted by recruiters and headhunters multiple times a week, and I thought I was in a good spot. Like, I thought I was secure in my role, everything like that, and then I got let go in May, and the bottom kind of dropped out of the market. I want to say sometime in 2023, and I'm waiting for it to come back. Hey, what's up, Sionix? Or Sionix? Sionix. Hello there. All right, so I need to rename rule base to rule. So we're just going to do this. And rename symbol. Where are you? Here it is. To rule. Save that. And I got to rename the file because I'm in Visual Studio Code. And it doesn't do those things for me. There's that. For quick experiments, I use VS Code on my Mac. For the actual production work, I flip over to a remote desktop into an old Windows laptop that I found in the house, and I'll use full-on Visual Studio when I'm doing work that's going to make it to production. So once I get this stuff sorted out and tidied up a little bit, I'm going to move over to full-on Visual Studio and use that. But this little solution that I'm doing here, it was an experiment until this morning when the experiment worked. And I became quite happy with it. So I decided that I'm going to clean it up and actually modularize this thing and make it so that it's kind of drop-inable to any other solution that might need the ability to store this kind of information for, say, a validation rule or what have you, and then turn it into something that can actually run. So rule TV where T system object base, okay. And let's see if it's going to let me get away with this. No, I didn't want to do that. What the heck are you doing, VS Code? Here we go. Public static rule. Build rule. Rule definition. Rule def. Now it doesn't like that. Doesn't like that at all. And does a non-generic form of rule exist? It does not. That means I need to I'm going to have to do a little bit of refactoring on this, I think. What if I public interface IRule and we'll let Copilot do its thing. And get rid of, make this private. Make it private. Private. And get rid of the virtual. Make this private. And public bool execute object test object throw new not implemented just for now. Rule TV implements IRule. I'm going to get rid of this system object base type constraint. There we go. Because it's likely not needed. Public static IRule. Build rule. Okay. I'm using C#, see Onyx? And what I'm going to do is pop out here to Program CS and grab all of this stuff. Yeah, I could do it that way, but that's kind of hard to look at. Copy this. Paste it here. Rule instance equals rule ctor.invoke. And I'm going to do some tricky stuff here. My RuleDef to resolve that. I also need to pop out to program CS and grab get from type domain. Copy that. Come up into rule. Private static do the thing. Okay. I pasted that in a dumb place, didn't I? Nope. Nah, it's just the code formatting from the copy pasta. Let's pop this stuff in so that it's properly indented. And return IRule, or rule instance as an IRule. Get type from app domain. Okay. We might have to convert rule instance to an instance of RuleType. So GitHub Copilot. And I want to reopen editor with. There's a way to convert the rule instance to the type defined by the RuleType variable. And then to an IRule. Let's see what Copilot gives me. Let's get rid of that. Var rule equals, and I don't think this is going to be legal because we don't know what T and V are here. Convert dot change type rule instance to RuleType. There. That'll work. Okay, there's getType.appDomain. I am pretty confident with reflection. I've been using it forever. Okay, so let's save this. And out here in program.cs, what I want to do is, instead of all this goo, I'm just going to take this and delete it because it lives over in the class now. Var rule instance equals rule dot build rule from my rule definition. What's this complaining about? Ah, it requires 2 type arguments. But IRule, build rule. Oh. So what I got to do is pull this out of the rule class. And this X public static class rule factory give it the wigglies, give it a paste, save, pop over here, rule factory dot build rule, handing it my rule def. Good. Let's move this breakpoint here. Here we go. And let's push the button and see if it works. I just did a whole lot of FAFO. Excuse me. Oh, and we had a build failure. That's okay. Where's my problem? What's your problem? Theoretically, okay, there's a breakpoint. Converting null literal are possible. Sample rule does not contain a definition for evaluate. That's right, because it's execute. Sample rule can go away. It's BS. We're going to delete it. That was exploratory code anyway. Now, there is a problem in the actual the rule itself, in that execute is throwing a not implemented exception. So that's going to fail miserably. And my mouse is running out of juice. So I'm going to have to go to using the trackpad on my laptop while I feed the mouse. So, var typed t typed subject equals convert dot change type from test object to type of T. What are you complaining about? I think I could use a cord with this one, but I don't have a micro USB that's long enough. And being a former musician, I have a love-hate relationship with chords. Bool evaluation result equals execute with the type subject, return the evaluation result, save. And that's the Explorer. Where's build? Here's build. Yeah, I've got a love-hate relationship with wireless stuff. Like, I hate wires. Hate them. But I also don't trust wireless systems. Especially for like wireless performance, like wireless mics, wireless guitar jacks and stuff like that, because I have always run into problems with those at the worst possible moment. But cables and wires suck. I don't like wrestling with them. They're a pain in the neck and they bug me. All right, so public bool execute. I do have a gig on Sunday. I mean, former full-time professional musician. All right, so we've got all this stuff. Let's try, we've built successfully. Let's try running again. And it's going to hit our breakpoint when it goes to the, when it gets to the RuleBuilder.build rule. And I want to step in here. And we're just going to step over these things. Make sure subject type, not null. Operand type, not null. Get our rule type. So it just dynamically built a rule object, or the type of the rule object that accepts my subject and operand type. It got me the constructor. And rule CTOR is not null. Good. We get the type of the operator. We feed that into a new rule expression, which can execute that operator against a variety of well-known types. Comparison constant. Let's turn that into the appropriate kind of object. Let's invoke the constructor, make sure it's okay. Our rule instance is that. Wonderful. I wouldn't say easier or harder with Copilot. I have to think about it less. I just installed Copilot this morning. I've been doing reflection out of my head for 15 years. Here's this. And here's my rule instance. Now the question is, here's a couple of sample types that it's expecting. Will it blend? Let's step in. So we've got our test object. It's currently boxed as an object, and we need to unbox it to its ultimate derived type. So let's do that. Boop. Type subject is a sample type. Groovy. And execute. We'll step in. So the test prop value is 10. Where's our constant? We should have a constant somewhere around. Oh yeah, that's right. Test prop value is not null. This is just a little bit of stuff to make sure nothing bad happens. I don't have an is null evaluator yet. Test value equals. Okay, we've just cast that to the correct type. And now we'll step into evaluate. And we'll go into expression.evaluate. Expression is of type rule expression. And our evaluation strategy is equals. And we've got a class defined for the equals operator. So we'll step into that. Value to test is null, or base value is null. We are going to return false because you cannot evaluate equality against one or both null values, because null does not equal null. Null equals I have no frickin' clue. Null is basically the best way of expressing maybe as a binary thing. I have not been a teacher. I've kind of taken on teaching as part of my role as an architect and senior developer or lead developer or what have you. My dad was a teacher for his entire career until I moved out of the house, and then for a few years after that, until he retired, he was a teacher. And he was actually one of my teachers from 7th through 12th grade. He was my band teacher. And I have a ton of affection and respect for people that go into that profession. So, type strategies. What I've done here to handle the various different types and stuff like that is I've got this register known type strategies abstract. And for each operator, what I do is I create a function that performs that operator's evaluation against, the basic types: string, int, decimal, etc. Excuse me. Date, time, and then I'll add more basic primitive types to it later on. But I'm making heavy use of a strategy pattern here. So, strategy is not null. And you can see up here my type strategies. It's just a dictionary keyed on type with a function to resolve the equality operator, the whatever, for any of the types that are registered. There's an extension I want to make to this later. So, we'll just step over that. And this is going to invoke that function. So let's step in. And you can see our type strategies.add is just a lambda. So we're going to let that go. Step back out the stack. Our evaluation results should be true. Fantastic. And all done. Cool. So that worked nicely. I can actually pop over here. Get rid of that. I don't need it anymore. Goodbye. All right. So, remaining tasks. I've renamed rule-base to rule. Got rid of it. Get the reflection code out of program.cs and into a static builder method. Got it. I'm going to get to creating unit tests. I want to test one more concept here. So I've got this rule definition. I'm going to say, and we're just going to test equality because I haven't implemented the other operator kinds yet. So, account balance is equals 10. Rule definition. And let's rename this ACT rule. Name rule equals, there we go, name equals Tom, groovy. I want account rule, and actually I'm going to call this account rule def, name rule def. Rename symbol, account rule, and account rule def. Var name rule equals rule factory dot build rule for the name rule. And I'm just going to run these. Account result 1, bool, name result 1. We're going to execute the name rule against the dynamic test sample 1. Bool. Instead of dynamic, I'm going to call it account result 2. Bool ACCT, nope, name result 2. All right. So all of that should run just fine. And I'm going to move my breakpoint from here to here. And we're going to debug. And I'm just going to step over those executions this time. All right, so we've got account result 1, true, true. Account result 2 is false. And false. And there we go. So you would think that's pretty cool. I think it's pretty cool. But what if var list of IRule rules equals new let's get rid of these. If no, rules is the collection of rules that we need to run. So I'm just going to grab this. Copy that format over here. And you know what? I'm feeling silly. list sample type. Things equals new. Come on, Copilot. I only want 2 of those. Yeah. I don't know. Hard to say. I'm just going to cut this out of here. Paste it here. And I'll add another sample. I'll get rid of that. And validate all the things. For each. And get rid of that. So what I've done is I've put all of my rules into a collection. And I've put all the things, all the instances of the things that I need to validate into a collection. And so now, if I run, what it's going to do is we're going to validate Tom, and if rules.all execute every rule with our current thing, it'll say passed all the rules, failed 1 or more rules. Cool. Let's come to the one that breaks all the rules. And that's pretty cool. I like that a lot. I like that quite a lot. And so we could define these rules in the database. We can have, we could be looking for specific comparison constants, stuff like that. And then, of course, some rules apply to some activities and not others. So we store these rules, and then we can also associate these rules with the different actions, the different use cases that our subject may be participating in. And we'll be able to load these things in when the app spins up, build this collection for each activity, and create a validation engine. And when we need to add rules or alter them, we update the data. We don't have to update the code. I think that's pretty cool. Now, there's some more extension I want to do to this, but what I want to do right now is prepare this to be uploaded to a fresh, clean GitHub repo that I created in between this morning's session and this afternoon, so that I can share some of these concepts. I also need to implement the other operators. And I want to put some unit tests on some of this stuff. Although, honestly, the console app kind of shows how it works. It works rather nicely. And there's some extensions that I want to make. One of the things that I would love to do is not necessarily, well, on our typed rule, yeah, this would be an appropriate place for it. Have an optional property. Rule factory. This is all this stuff. I gotta put all these things into their own files. And I'm going to rename this to iSimpleRule. Rename simple to iSimpleRule. Public interface. Rule. Side effecting rule. Action of object. Side effect. I used a website builder application called AstroJS, and I guess it either wraps or modifies the React framework. And what it does is I basically create Astro files, and when I build the website, it converts all of those .astro files into dynamically generated at build time HTTP, CSS, JS files that and it's just a static website. It does all of the repeatable, the repetitive stuff for me automatically, based off of little formatted strings I put into the Astro files as I'm building it. It's pretty neat. It is very plain on purpose. I didn't want to have it like all flashy and pretty and full of graphics and so on and so forth. I'll probably iterate on it eventually later. Yeah, its performance is super fast because I wanted the stuff on the server to be stupidly simple. Like literally just static HTML, CSS, and JavaScript. Now, in building my Blazor application, I did find some really, really cool tricks for icons that I'll use throughout the application, like little icons for buttons and stuff like that. Instead of using PNGs or JPEGs or GIFs like I would have 20 years ago, I am using SVGs, scalar vector graphics, but instead of actually keeping those as files in the www.root/images folder, I get the vector definitions for the SVG files and I inject them directly into CSS classes. And then all of those images download with the main CSS file, so I'm not constantly making, or so I'm not making a request to the server for every little image. Because when you're mobile, the biggest bottleneck is the space between your cell phone and the nearest cell tower or Wi-Fi access point. So it actually takes a considerably longer or a considerably greater amount of time to make, say, 10 requests for 10 kilobytes each than to make one request for 100 kilobytes. Yeah. Yep. So like, let's say we have to pull down 100 kilobytes. In the old hardwired Ethernet days, it might have been more efficient to download more smaller chunks. Basically have a chattier load conversation between browser and server. Yes, very much like that. Yeah, that's exactly the technique that I learned and used. So in the olden days, it might have been faster to actually go ahead and make 10 calls for smaller payloads. But as the technology has changed and matured over time, those individual calls take a variable amount of time. If you're hardwired, it's negligible. Like if your laptop is connected via Ethernet to your router and you're on a gigabit connection, like we are here at my house, I mean, who cares? But if you're on a mobile phone, the most time expensive part of downloading a website is negotiating the connection between your phone and the nearest cell phone tower or Wi-Fi access point that your phone's allowed to connect to. And if you're on pure cellular, I don't care if you're 5G or 5G extended or, telepathic Ansible modems or whatever, it's still the most expensive part of that process. So yeah, even if it's only 10 kilobytes or like a couple hundred bytes in a file, it takes longer to connect than it does to actually transmit the file. And that's one of the things that was discovered shortly after Muskie Guy bought Twitter. And there's that big story about how he had found, all kinds of inefficiencies in how the Twitter code executed and everything like that. And it turned out that at the time that he bought it, the way the Twitter homepage worked is it made a call to the server to download just an index of all of the tweets to be displayed, and then would make a single request for each tweet on that within that index request. So every time you go to load Twitter, it'd spin up 20, 30, 40,000 individual requests to the back end. And if you're doing that from your phone, that's going to take forever. Even though each request can be, processed as it happens in an asynchronous manner and so on and so forth. Oh, it's way worse. So when you're designing for a mobile experience, you want to make sure that the messaging between client and server is super chunky, that you send down as much as you can, reasonably speaking. You don't want to send down gigabytes every request. But if you've got a choice between sending a large number of small messages that are exactly what the client's going to need versus one larger message that has some information that the client application may not need, but it cuts down on the total number of requests, you want to go for chunkier interactions between your front end and your back end. If that makes sense. And as a back-end API developer, that made perfect sense to me. Is like, I don't want people hitting my server a million times a second. I want them to hit it once, get back all the things that they might need, and then carry on from there. But yeah, iasync enumerable. I have used iasync enumerable inside of local process context use cases. Like, I'll initiate the async enumerable and consume it, but the initiation and the consumption, in my mind, really need to be within the same compute process. Like the components need to be linked at the binary level versus a networked communication level. Reason being is marshaling that async enumerable process over remote control can get really goofy. Not a fan. If I needed to implement an async enumerable return, I would probably fall over to WebSockets, where the request for the information would be made via HTTP post that would return to the client immediately. And then that would spin up a process on the server that would start, like, as results arrive, would start pushing those results down to the client via WebSockets or SignalR. And that'll keep the client nice and responsive. And then, of course, you would need code in the back end of your browser client that can accept those messages and either discard them if they're no longer relevant, or process them and update the UI through that way. So a side effecting rule. This is an interface that I just created, and what it is it's not a rule that just executes and returns true or false. This is a rule that executes and instead of side effect, I'm going to call it false effect. And let's add a little bit of description to this. I'm not going to implement this now because I try to only stream for an hour at a time. Yesterday I went over I think my afternoon session was like 2.5 hours. This morning I was like an hour and 15. This afternoon I'm closing in on an hour and 15. But yes, I've done the exact same thing. Yeah, exactly. And what I've done in the past when I've had to do that exact thing, Scott, is hook up a SignalR hub in my Blazor server side, and I would send my chat message from the UI to the back end as just like a straight up HTTP post, and then the backend controller or the API endpoint method, if you're using minimal API, would enqueue that request to an internal in-memory queue, and then return immediately saying, "Yep, I got your chat request. Carry on." And then the AI component is watching that queue for incoming chat messages. Excuse me. Pulls it off the queue, passes it out through semantic kernel or whatever, starts getting the async enumerable, and as on each iteration through that async enumerable, it essentially raises an event back out to the SignalR hub saying, "Send this part of the response to this client." Because the client would be connected both to a standard HTTP API and a SignalR hub for those disconnected transaction or disconnected async results to flow back. I haven't needed that yet. Not for these projects I'm working on, because that gets complex. That gets really complex. Oh no, you don't create the API with SignalR. The API is just like, it's plain vanilla minimal API or API controllers, whatever. But the response, the actual response, the result of the workload comes down through SignalR eventually. It doesn't come back as part of the API response. Yeah, you could do that. And I think the OpenAI API actually does present a streamed response endpoint method that's exposed as an IAsync enumerable on the return type of that particular method. But those freak me out. Executes the rule and return the rule. This needs to be nullable. Executes the provided action if the rule is false, then returns the result of the rule evaluation. Test object, the subject of the rule, the action to take if false. That's a little bit more advanced, what I just spec'd out there. And then, of course, there's another form of this, is an immutating rule that would public interface mutating rule and this would be a bool execute object. And what's the name of this thing? Yeah, test object. Fine, I'll keep it consistent. Object. Action. Object. Nullable. False. Effect. Out. Object. Mutated subject. This form of a rule will evaluate the rule against the test object. If specified, it will execute the false effect action against that test object. The return value is the result of the rule evaluation. The test object is returned in the out parameter. And that's where we start to get really fun. All right. Blazor server, which updates with status change. Yes. Yup. That's what I've used. All right. I think I'm going to call this a completed session. I'm probably not going to implement side effecting and mutating rule. Those are concepts for later. Later may never come. But I've got the iSimple rule defined. It seems to be working just great. I am going to need a side effect eventually when I get into validation with these things, because I want the validation process to return a decorated version of the subject of the validation process. But that's for later. I'll probably do that code work offline and then discuss it once it's done next week. On Monday, we're going to pick back up with the design aspects for the admin system for the software as a service that I'm building, called the DM's Familiar. But we'll talk more about that later too, because I have some groundwork to do to actually bring that to life in the real world. So until next time, thanks for joining me. Scott, if you dig it, I've certainly really enjoyed our conversation. Please follow me. I'm not an affiliate yet, so you couldn't subscribe if you wanted to, but please give me a follow. And I want to carry on talking like this. This is great having you here. I appreciate your joining me and your very intelligent contributions to the question, or to the session. So that's awesome. I'm glad you hung out. And have a great weekend, folks. I've got D&D tomorrow. I've got a solo show at a local tap room that my wife and I like to frequent on Sunday, and then I'll be back at this on Monday morning. So until next time, take care of yourselves, do fun things, eat good food, drink fun drinks, and water. Don't forget the water. And be good to yourselves. Happy coding, kids. See you next time.